Welcome back to Realcomm Live. I'm doing 3 in a row, but I'll tell you, each one are topics that I could talk about for hours. I just got finished with the developer of Tampa Water Street, and I said I've been to a lot of cities with this conference, and we intentionally try to find cities that are innovative. This could very well be the best city in the United States. From a design standpoint. And what I mean by that is, think about the macro design of what they did here. 5 hotels facing a convention center with state-of-the-art technology, windows in their rooms, walls that move, a walkway that allows people to exercise in the morning before they go to their meetings, technology district, 5G envelope over the entire district. These guys are on it. Cool. And these are the kind of people you all want to find because they're innovative. They don't just talk innovation, they do innovation. And I think given where you are in your journey, and we'll talk about that in a second, you can be selective with the people you deal with. And if you talk to people who want to kick your tires and take 2-3 years of your lives, go find the people that are ready to move tomorrow. And a lot of them are in this room. All right. So, big topic. It's not low voltage anymore. You've retrained me. It's DC power, which incorporates high voltage and low voltage. And what that means is, as I mentioned in the general session, that goes back to the 1893, I think was the date. Tesla and Edison battling it out at the Chicago World's Fair to light the fair, which would determine a standard that would light the whole globe, the entire world, for the last 150 years or so. Right? So that was a big battle. I don't think they realized how big of a battle it was.
No.
But AC won, alternating current won, for a number of reasons, which I'm sure we're going to talk about. And I call it the sledgehammer. You know, early on it was electricity, but as I've learned more about you folks, AC feels like the sledgehammer, and DC, especially when you get down to the low voltage side, it feels like a laser beam, right? And especially what you're doing with high voltage, right? So just to let the audience give them some context, why don't you each take a minute, introduce yourself, and then once we get back to that, I got 4 hours of questions, and we'll get through 10 minutes of them. Sebastien.
Sounds good. Yeah, I'm Sebastien Gouin-Davis. I'm the CEO of Loom.io. We've got a lighting controls background, and we've been partnered with other DC lighting companies for almost 14 years now. So we've got a lot of experience, but different technologies, right? Even the DC space has changed a lot over the last number of years. So what we've built with XPOE, we think is sort of the culmination of all these technologies coming together. We watched what PoE lighting was doing for a lot of years, and ultimately we do think that using Ethernet cables to power lights is the right way to do it. You got power and data, it's an international standard already.
Yep.
The problem that it's had historically is it's just been way too expensive. So we went deep to try to figure out, first principles, lighting as a first-class citizen, still completely reverse compatible with Wi-Fi routers and security cameras, right? All the off-the-shelf stuff, but we wanted to figure out how to reduce that cost so that you could just lower the barrier to entry, right?
So I pitched all of you guys yesterday as the first chapter of the next book. The first book was building automation, one building, one system, one company, nobody talked anything.
Yeah.
Second book was connected, integrated, interoperable, IP-based, right? More IT presence, last 20 years. And then what we demonstrated yesterday in the general session was, I believe, the first chapter of the next book of smart buildings.
Yeah, I mean, all of the technology that we're going to talk about here just inherently has the data collection, the energy metering, and the control that we need. I think for the last decade, we've been slapping that stuff on top of buildings or trying to make it work with legacy tech. And the idea of building buildings that aren't inherently ready for the next wave is, we'll come back to security later, but because I think that's an interesting topic here, even if we touch on it quickly. But yeah, it's got to be done at this point, right?
And just a final note, when Farukh invited me to your showroom in Orange County and you lit the lights, I got it immediately. Yeah. And you guys all graciously agreed to work together to do that demo in the general session yesterday, which brought together 5-6 technologies. I don't think that's ever before been seen.
It's pretty cool, and I don't want to use all the time, but one thing I do want to make really clear is like, although this is the first time these companies have worked together, like we didn't have to invent anything to pull this together, right? These are
you just had to plug it all in.
It was more of a logistics challenge and making sure we could get it in, 3 weeks to get it from California to Chicago and back over here.
Yeah, and you guys committed and you made it happen.
Yep.
Mahmoud, I mean, you're the high voltage part of this conversation.
The safe high voltage.
Safe. Yeah,
Yes.
You can bite the wire, right?
Yes. Actually, kudos to you for bringing us all together and actually making this happen. So, because you actually brought us all together.
But it couldn't have happened without a crazy good collaboration.
Yeah. So I'll just introduce myself. I'm Mahmoud Ibrahim. I'm a senior business development manager at Panduit. And Panduit has been around for 70 years now. We manufacture products for networking and for electrical. And the recent innovation that we brought to market is fault managed power, or the class 4 power system. And that basically talks about the safe distribution of high voltage. And that's kind of, for us, it's been the missing piece.
Right.
What's really new is similar technology has been around, but now it's in the standards, it's in the electrical code, which we hope is going to help the adoption of this technology.
And let's go back to that Chicago World's Fair. One of the reasons that, or maybe the main reason, that AC made it and DC direct current did not, was because of the danger of direct current.
Okay.
Correct?
There were two main reasons. The big one was actually distance.
Right.
So they couldn't, as Tim said, we didn't know back then how to take DC, make it high voltage so that we could take it a long distance and then step it back down efficiently, and how to turn it on and off once it was up at those high voltages.
Got it.
And so, there's the perception is always that voltage drop is the biggest issue with DC, and it is a challenge, but AC has voltage drop problems too. It's just not as bad.
But you've managed to take high voltage, send it down a very thin wire safely.
Yep.
Correct. So, just in a nutshell, the way it works, we can take AC or we can take high voltage DC, but then we manage it. We pulse it and manage how that electricity is transformed over the cable. So you can use 16, 18 gauge, very thin cable, and we're able to detect up to 2 kilometers away, which can cover any building out there and most campuses as well. Detect if someone touches the cable or if there's a short circuit or any kind of fault.
Yeah.
And if it happens within milliseconds, we're able to turn power off.
Brilliant.
So really,
Absolutely
the management
brilliant.
part that was missing is now we're capable of doing that.
Right. I'm a non-electrician and I get it, right? And if I can get it, any building owner, developer in the world should be able to get it. Now, you are the developer, Farukh. You're a geek. Let's make sure you are a geek. You're an engineer, so kudos to that. But you're also a developer, right?
Yes, I am. I realized in 2016, after completing a hotel project, that the building infrastructure, mainly electricity, is the same for over 100 years. While the load has changed, while the endpoints, the connected load has changed tremendously, starting with LED lighting. LED lighting, 100% are low voltage DC devices. So nobody thought to go back. While new devices come in, they figure out how to connect to the existing AC power. But nobody has taken a challenge to, why don't we change the power coming into a building? And that's what led me on a quest to see, is somebody working with low voltage
I've been
DC
asking that question for 20 years after I first saw that gentleman in Tokyo take that RJ45 and plug it into the lamp. And I said, why is everybody focusing on generating renewable energy just to shove it into an inefficient architecture? Why don't we rethink the whole thing? And big venture capital money, Washington, all the energy department, nobody's having this conversation. And now we did have the administrator from GSA here, and I'm going to push for a meeting with the GSA, with the club or with the cult.
Well, some of her guys reached out, came over to the booth.
Awesome.
We had some really good conversations.
Okay,
too,
so that's already started.
Well, no, you can.
But I
keep the
think
momentum.
But I think a day summit or something like that, where we just get in there and talk about the possibilities, the risks, and.
But I just want to be clear, like what your presentation yesterday, that got their attention.
That was the goal.
Yeah.
That was the goal.
There is an education element to all of this, and we need to keep talking about it more and more so people can actually get the big picture.
Absolutely. Yep. All the way from the UK, Tim Hobbs. What are you doing here?
For 35 years, Jim. Thank you very much. I've been the CEO of a company that distributes power within the room in offices. So in commercial offices, we're now moving into a lot of other verticals, but we're still in offices. and getting power, AC power, to all the devices and the people within the room. In the last 6 years, we've developed a DC solution. It's to marry up with the new agile hybrid working, getting people back into the offices, not working at workstations, needing soft areas to work at, cafeterias, things like that. And with that DC solution, which is a battery solution, people can take the power to where they want. But where we're doing everything in the room to get power to people who need to use it whilst they're in the workplace, that marries up really well with the fact that these guys are doing all of the DC work around the room.
Well, I want to challenge you though.
Whole
are you staying at the Marriott?
I'm not staying at the Marriott.
Go
no.
walk over the Marriott before you leave. They've got digital signs that aren't glued to the wall, finally.
That's cool.
They're on wheels, so when the traffic isn't on the left side of the building, they can move these things, but they still need a plug. Go, and I know the manufacturer of those devices, they need a battery pack so they can be moved anywhere around, and I don't have to pay $110 to drop it.
He's going to take us to Marriott himself. He's actually going to show one of our digital signs. We've got a digital sign here in the show, which is actually cable-free, 43-inch monitor, powered from one battery for the whole day. So that means that you can go into the retail sector, you can go into, I mean, we could talk to Walmart, they're here today.
This is
completely cable-free.
What happened to the automobile industry?
That's what I was going to say. It's like I think the electric vehicle is the best analogy here because, you know, electric vehicles aren't new and DC power is not new. But to build a really good electric car, they had to start from the bottom up, right? And for a lot of years, Ford would take a Focus and rip the motor out and stick an electric motor in there, and that was just never going to be something that was the experience you get from a Tesla or all of the other amazing cars. And everyone I know who has an electric car, they just love it. They love everything about it, right? And not just the green stuff and not just the self-driving. It's like the whole experience. It's just better. And that's my favorite part about the moment that we're at right now, is it's not a science project.
Well, it was my daughter's science project in 8th grade, which I showed on the screen. I mean, somebody goes, your daughter really liked solar to LED? And I go, I probably had a little influence on that topic. But here's the ironic part. And it was so common sense good, but it went over the heads of the science judges. I mean, because and these were the kids teaching our kids, they just couldn't understand it. And I said I knew we had a lot of work to do in the education side because it's almost so simple that it's hard to understand, right?
And it is simple. I mean, in the slide you've got behind us, Jim, all of us are just showing how we can move power, DC power, which is then you can get data from that DC power, you can work out how much people are using it, where they're using it, what they're using it for. So there's so much data in DC power that isn't available in AC. But that slide shows how we can move 2 kilometers, 100 meters, 25 meters, and the last 5 meters to the user.
Right, and just so to be very clear on what could be perceived as a complex topic, you're the long distance run,
correct.
You're the ceiling and walls, you're the mobility,
in the room.
You're the developer who pulls it all together to make it work.
Correct. And I mean, a theme for this conference yesterday, all the keynotes talked about monitoring and control and data.
Right.
And that's inherent to all of our systems.
And I'll just throw within a very high awareness of privacy.
Yeah.
I mean, we're going to go down some roads that are going to give us capabilities that we need to be very thoughtful on how we manage, because there's other places in the world that don't care about privacy, and we don't want to become those places. So,
good stuff.
One final thought, because Mary's looking at me. We're out of time. 5 seconds.
Final thought is on the security piece. I think it's easy to say, hey, we're going to put smart stuff. It's going to be more security risk. I just want to be really clear that it's not actually safer to leave the old stuff around. You know, running MSTP cables and all the ancient technology is actually easier to hack. And as Jim Baldwin said yesterday, you can't continue to upgrade that as new attack vectors are identified. No. So we will solve the security stuff. The whole world is trying to do it. Banks have done it, and it's going to be solved.
Mahmoud.
Thank you for bringing us together.
My pleasure.
I hope this is the beginning of people to really see that this is true. It's happening.
It took 20 years to get you together, but we're here.
Yeah, but and to do the lighting display that we did yesterday, it was just logistics, but the technology is here today and it works, and you can buy it. So I hope people.
I'm actually going to see if I can get the Tampa newspaper down here and take a picture of that. I'm going to talk to somebody, see if we can make
Better
that
hurry,
happen.
because we're going to be taking it down soon.
Yeah, as soon as we're done.
So I have seen more advancement in the past 12 months in this technology than I did in the past 6 years.
Yeah.
So it's really turning a curve now in becoming mainstream.
Yep.
We are doing projects that are very significantly large, so it scales. You know, like earlier Sebastien said, this is not a science experiment anymore. This is as real as it gets.
Yep.
We can easily do a 500,000 room hotel with all kinds of controls using this technology. So it scales very well.
Tim, final thought.
I think we're in a time where we can have our cake and eat it. I think we can now, with the solutions we've got, we can make buildings cheaper to build. They can actually be cheaper to run. They're more efficient. DC can be more sustainable because of the efficiency. It's safer, and people can be more agile in the office. The lights will turn on when they walk into the room. We can actually power them while they're walking around the room. So the people working in the workplace get what they want. The tenants of the building get what they want. Everybody can have a cheaper, more efficient and sustainable future.
Yeah, and this is a new book. This is not another chapter. This is a new
right.
book. And I want everybody to take a look at these faces because they're going to be famous. And you can say, I saw them first at Realcomm.
Thanks, Jim.
Realcomm out. Thank you.